I'm evaluating a model's performance using the area under the ROC curve, AUC, score. The AUC is 0.75, and I need to determine which statements about this result are correct. The ROC curve shows the model's performance at various thresholds and the AUC summarizes this curve. Let's analyze each statement. This statement is true. An AUC of 0.75 is better than 0.5, which represents a random guess. An AUC above 0.5 means the model performs better than simply flipping a coin. This is false. The AUC doesn't directly measure the percentage of correctly classified instances. That's accuracy. The AUC measures how well the model ranks positive instances higher than negative instances. This is true. Since the AUC is greater than 0.5, the ROC curve will be above the diagonal line. The diagonal line represents random guessing, so being above it is a good thing. This is true. An AUC of 1.0 means the model perfectly separates positive and negative instances. It's the best possible score. This simply shows the value of the AUC. Remember, AUC stands for area under the curve. It's a summary of the receiver operating characteristic, ROC, curve, which is a graph that illustrates the diagnostic ability of a binary classifier system as its discrimination threshold is varied. I'm evaluating the performance of a binary classification model using a metric called the area under the ROC curve, or AUC. It's a really useful way to assess how well the model can distinguish between two classes. This means the model achieved an AUC score of 0.75. That's a pretty good score. It's above 0.5, which represents random guessing, indicating the model is performing better than randomly assigning classes. With an AUC of 0.75, I can say the model's performance is better than just guessing. Remember, AUC is not a measure of the percentage of correctly classified instances. That's accuracy. Instead, it tells me the probability that my model will correctly rank a positive instance higher than a negative one. This question asks you to interpret an AUC, area under the ROC curve, score of 0.75 in a binary classification model. I'll guide you through each statement. We'll figure out what it means. It's all about understanding what AUC actually tells us. Get ready. This statement is true. An AUC score of 0.75 is greater than 0.5. An AUC of 0.5 means the model is performing no better than random chance. Since 0.75 is above 0.5, your model is doing better than simply guessing. Awesome, right? This is false. AUC doesn't directly measure the percentage of correct classifications. That's accuracy. AUC measures how well the model can distinguish between the positive and negative classes, regardless of the number of correct classifications. Think of it like this. A model could correctly classify 75% but have a lower AUC if it struggles to rank positive instances higher than negative instances. This is true. The ROC curve shows the trade-off between true positive and false positive rates. An AUC above 0.5 indicates the curve is above the diagonal, which represents random guessing. This is a great visual confirmation that the model is better than random. Nice. Absolutely true. An AUC of 1.0 means the model perfectly separates positive and negative instances. It ranks all positive instances higher than all negative instances. That's the ultimate goal. Excellent work. I'm assessing how well a model works at sorting things into two groups. Think of it like sorting emails, spam or not spam. Let's figure out which statements accurately describe what the area under the curve, AUC, score of 0.75 means. This score tells us about the model's performance. Nope. The AUC score isn't about the percentage of correct classifications. That's accuracy. The AUC score tells us how good the model is at distinguishing between the two groups. This is our result from using the area under the receiver operating characteristic curve, AUC ROC, calculation. It's a number between 0 and 1, indicating how well our model separates two groups. A score of 0.75 is better than random guessing, 0.5, but not perfect, 1.0. This is true. Because 0.75 is greater than 0.5, random guessing, our model performs better than just flipping a coin. Absolutely. The ROC curve shows how well our model separates the groups at different thresholds. An AUC above 0.5 means the curve is above the random chance line. You got it. A perfect AUC score of 1.0 means the model flawlessly separates the two groups. That's the ultimate goal. We're assessing how well a model distinguishes between two categories. Think of it like sorting emails into spam and not spam. This is our model's performance score, a number between 0 and 1. 0.75 means it's doing better than random chance. An AUC of 0.5 would mean pure chance. It's like flipping a coin. This is incorrect. AUC doesn't directly tell us the percentage of correct classifications. That's accuracy. AUC measures how well the model ranks positive instances higher than negative ones. This is true. AUC is the area under the ROC, receiver operating characteristic, curve. If the AUC is above 0.5, the curve sits above the diagonal line, representing a random classifier. Absolutely correct. An AUC of 1 means the model perfectly separates the positive from the negative instances. I interpret AUC as the likelihood that the model correctly ranks a randomly selected positive instance higher than a randomly selected negative instance. It's not about the percentage of correctly classified instances, but rather how well the model distinguishes between the two classes. Think of it like this. A higher AUC means the model is better at separating the positive and negative cases. The ROC curve displays the trade-off between true positive rate, sensitivity, and false positive rate, specificity, at various classification thresholds. If the AUC is greater than 0.5, you will see that the ROC curve sits above the diagonal line, showing the model performs better than random guessing. A perfect classifier has an AUC of 1.0. This means the model perfectly separates all positive instances from all negative instances. It's the ideal scenario, but rarely achieved in real-world applications. An AUC score of 1.0 signifies a perfect model. In other words, the model can flawlessly distinguish between positive and negative cases, with no overlaps. It's the gold standard, but often unattainable. This part introduces the main topic, which is evaluating the performance of a binary classification model using the area under the ROC curve, AUC. I'm going to focus on understanding what the AUC score means and how to interpret it. When the AUC is greater than 0.5, it indicates that the model's performance is better than random chance. Graphically, this means the ROC curve will lie above the diagonal line on the ROC plot. This sets up the problem. You get an AUC of 0.75 from a binary classification model. The goal is to determine which statements about this result are correct. This part sets the stage. It introduces the concept of evaluating a binary classification model using the area under the receiver operating characteristic, ROC, curve. The AUC is a key metric to quantify this.